Right. Here is a problem from section 4.2 of the book on extreme values. The problem says to find the minimum and maximum of the function y equals the square root of x plus x squared minus the square root of x on the interval from 0 to 4. Okay, so let's see. Let me rewrite our function here. So it's y equals the square root of x plus x squared minus 2 square root of x. Okay, great. And we want to minimize this and maximize it on 0, 4, the closed interval 0, 4. Okay, so to do this first we need to find the critical points. And to find the critical points we'll take the derivative. So let's see, we get 1/2 x plus x squared to the negative 1/2 times the derivative of that inside function, which is 1 plus 2x. And then we'll have minus 1/2 x to the negative 1/2. Okay. See what's going on. So let's see, it's 1 over 2 square root x plus x squared, 1 plus 2x in the numerator, minus 1 over 2 square root of x. Okay, so this is the derivative. Okay, and maybe I'll simplify this, try to get this to look as simple as possible. So I'll combine these two fractions. So the first one I have to multiply by the square root of x over the square root of x. So I'll have 1 plus 2 x times the square root of x minus the square root of x plus x squared all over 2 the square root of x. I can combine these square roots, okay, since they're getting multiplied together. Okay, so if I'm looking for the critical points of this, I'm either looking for points where this derivative doesn't exist or where the derivative is equal to 0. So y prime, it doesn't exist when x is equal to 0. Then the denominator here would be 0, and y prime is undefined. However, x equals 0 is in the domain of our original function. So x equals 0 is a critical point. So that's one critical point. And y prime equals 0 when 1 plus 2x, when the numerator is 0. So we need to figure out when is this 0. So I think what I want to do is I'll say 1 plus 2x times the square root of x should be equal to the square root of x plus x squared. And now I'll just square both sides and say, okay, 1 plus 2x squared times x is equal to x squared plus x. Okay, I'm going to erase some of this top stuff and move, now that we've got the derivative. Just leave some of that there. Okay, so let's see. If I expand out the left-hand side So I'm still solving for when y prime equals 0. If I expand out the left-hand side, I get 1 plus 4x plus 4x squared times x equals x squared plus x. Okay, so let's see, I get 4x cubed plus 4x squared plus x equals x squared plus x. So these x's cancel. So I get 4x cubed plus 3x squared equals 0. Factor out an x squared from here. So we either get x equals 0 or x equals negative 3/4. Okay, so I guess, actually, I didn't even notice this. More confusing. This derivative at 0, it's an indeterminate form. It's 0 over 0. We have to put the limit. So the derivative at 0 doesn't exist, actually. So it's actually not equal to 0. In any case, 0 is a critical point. Something wacky is going on with the derivative. Doesn't exist. But we also have this other critical point, negative 3/4, where the derivative is equal to 0. The denominator is not 0, but the numerator is. Okay, so let me just clear this whole thing, and let's see. Okay, so we said that the critical points were x equals 0 and x equals negative 3/4. Now, negative 3/4 is not in the interval we care about, so, which is from 0 to 4. So we actually will not consider that critical point. We will we only look at the critical points that are in our interval. So we want to test our critical points. And we want to test the endpoints of the interval we care about. These are our candidates for where the minima and maxima are. So let's see, y of 0, y of 4. There are no other critical points or endpoints. So if we plug in 0, the value is 0. If we plug in 4, let's see, we get the square root of 4 plus 16 minus 2 square root of 4. So that's the square root, the square root of 20 is 2 square root of 5 minus 4. Okay, and the square root of 5 is a little bigger than 2, so this is bigger than 0. So the minimum is y of 0, which is 0, and the maximum is y of 4, which is 2 square root of 5 minus 4. Okay, so all we did was we took the derivative to find the critical points, which is where the derivative didn't exist or was equal to 0, and then we just evaluated our function on the critical points in the interval and on the endpoints of the interval. And we found the minimum was 0 and the maximum was 2 square root of 5 minus 4.